I'm going to walk through my thought process in verifying that 1 plus cosine of 10x is equal to 2 cosine squared of 5x. Now, when I look at the left-hand side of the equation versus the right-hand side of the equation, I notice that the angles are not the same. So I'm going to have to make the left-hand side have an angle of 5x. Well, how can I do that? We know that the cosine of 2 times an angle is equal to cosine squared of the angle plus sine squared of the angle. Not plus, that would be a minus. So if I say cosine of 2 times 5x is equal to cosine squared of 5x minus sine squared of 5x, I would be successful in getting the same angle that I have on the right-hand side of the equation. So that's what I'm going to start with. I'm going to start with replacing cosine of 10x with cosine squared of 5x minus sine squared of 5x. Cosine squared of 5x minus sine squared of 5x. And I'm going to rewrite 2 cosine squared of 5x so that I remember what it is that I need to get to. And that will help guide me on the left-hand side of the equation. For instance, on the left-hand side of the equation, I have 2 different trig functions. I have cosine and I have sine. But on the right-hand side, I just want cosine. So I need to replace this sine squared of 5x with something that I hope will be just in terms of cosine. So sine squared of an angle is equal to 1 minus cosine squared of that angle. That's a Pythagorean identity coming from sine squared plus cosine squared equals 1. So I'm going to replace sine squared of 5x with 1 minus cosine squared of 5x. That's going to give us 1 plus cosine squared of 5x minus, and then in parentheses, I'm going to substitute in 1 minus cosine squared of 5x. And once again, I'm going to rewrite 2 cosine squared of 5x so that again, I know what it is that I need to get to. Step 3 is just going to be simplifying. So I'm going to distribute the negative sign, which will give me minus 1 plus cosine squared of 5x. Keeping in mind that the right-hand side is still 2 cosine squared of 5x. Step 4, 1 minus 1 becomes 0. And cosine squared of 5x plus another cosine squared of 5x becomes 2 cosine squared of 5x. I have successfully made the left-hand side look identical to the right-hand side. Therefore, it took me 4 steps and I am done. You are going to get better at this through practice. So seeing as many of these problems as we can and getting as much practice is going to help expose us to all the different scenarios we might see. But quite honestly, there's so many scenarios that it's hard to show you exactly one way to do these problems. The more you know your identities, the more comfortable you're going to be going through this verification process. There are many different roads to verifying that the left-hand side is going to look like the right-hand side. It all depends on which route you choose to take. So in this next example, we have cosine of theta plus 2 sine squared of theta over 2 equals 1. What I see is 2 different angles. We want the same angle. So we really want to try and get the same angle. So I'm going to write that note right there. We want to try and have the same angle. It would be easier if we had everything in terms of theta. It would also be easier if we didn't have this squared with what we know to be let me come back here. We know sine of theta over 2 is going to be a square root. So that squared with the square root is going to help things out significantly. So we have 1 minus cosine of theta over 2, which is what sine of theta over 2 is equal to. So I think that's where we're going to start. Cosine of theta is going to stay put just for now. And then I have plus 2 times, and in place of sine squared of theta over 2, we're going to have plus or minus the square root of 1 minus cosine of theta over 2, and then we're going to square that from the square that's right there. And then that is equal to 1. So we have our left-hand side and our right-hand side. Let's continue to work with this left-hand side. Cosine of theta plus, now the plus or minus, the 2 stays. The plus or minus, when I multiply that by itself, it's going to become positive. The radical times itself will undo that radical, that square root, and we'll have just the radicand left over. Step 3, when I multiply fractions, I'm going to multiply that fraction with the 2 and then the 1 minus cosine of theta over 2. When we multiply fractions, we multiply straight across. However, we can also cross cancel. So this 2 is going to cancel out with this 2, which is going to leave us 1 minus cosine of theta in the numerator over 1 in the denominator. So we just have 1 minus cosine of theta. And then simplifying, cosine of theta minus cosine of theta cancels out, and we are left with 1 equals 1. The left-hand side is identical to the right-hand side, which tells us we have completed our task.